Conversions of moles to representative particles and vice versa. First, couple of definitions. What is a mole? What is a representative particle? Starting with representative particles. Representative particles are simply the type of particle that makes up a substance. There are two types of substances. There are elements and there are compounds. Elements are made up of atoms, and so atoms are the representative particle of an element. Compounds can either be ionic or molecular. Ionic compounds are made up of unit formulas, therefore they are the representative particle of ionic compounds, and molecular compounds are made up of molecules, so they are the representative particle of a molecular compound. So three types of representative particles: atoms for elements, unit formulas for ionic compounds, and molecules for molecular compounds. So if I asked you what is the representative particle of zinc, you would say it's an atom because zinc is an element. For aluminum nitrate, it is the unit formula because aluminum nitrate is an ionic compound. For sulfur trioxide, it's the molecule because that's a molecular compound. Iron 2 chloride is an ionic compound, so the unit formula is the representative particle. C6H12O6, all non-metals, so that's a molecular compound being composed of molecules. Magnesium oxide is ionic, so it's the unit formula. Same for lithium phosphide, ionic compound, so it is made up of unit formulas. So representative particles are the types of particles that make up a particular type of substance. And the mole is the metric or the SI unit for the amount of a substance. You got to think of it as just one great big dozen. So just as 1 dozen always equals 12, 1 mole always equals 6.02 times 10 to the 23rd representative particles. That is a huge number, 10 to the 23rd. That's a million, billion, billion, to give you a sense of how big a mole is in terms of the quantity of particles. 1 mole of marble spread over the earth would result in a layer estimated to be 3 miles thick. If you have a dozen eggs, that would make a huge omelet. But if you had a mole of eggs, it would fill all of the oceans on earth an estimated 30 million times over. It would take 10 billion chickens laying 10 eggs per day more than 10 billion years to lay 1 mole of eggs. But since chemistry deals with very, very small particles, you need a lot of them to make up a significant amount, and so 1 mole is Avogadro's number. To convert between moles and representative particles, the equivalent is 1 mole equals Avogadro's number. So if I asked you how many unit formulas are there in 2.2 moles of silver nitrate, again, this is my known, this is my unknown. I want to convert from my known to my unknown, and so I need to use dimensional analysis for this. You always put the unknown or the known on the outside, 2.2 moles, and then we're going to put the mole unit on the bottom of our equivalent and Avogadro's number on top. That way moles and moles are going to cancel, and if I have 2.2 moles and 1 mole is Avogadro's number, I'm going to have 2.2 times as many unit formulas, and so we're just going to multiply Avogadro's number times 2.2, coming out to 1.3 times 10 to the 24th unit formulas. Note, we can have 2 significant figures on that one. And then if we go the other way around, if I give you molecules and ask you for how many moles, now we want the molecules on the outside. That is my known, and my unknown is the number of moles. And so now we're going to put Avogadro's number on bottom of molecules, molecules being the representative particle of water, and 1 mole on top. Now molecules and molecules are going to cancel, and now I'm going to divide by Avogadro's number. Be sure you put Avogadro's number in parentheses when you divide, and that is going to come out to 5,800 or 5.8 times 10 to the 3rd moles. So just converting back and forth, you're either going to have 1 mole on top, Avogadro's number on bottom, or the other way around.